Hello, this is the video for submission 94, Uncovering Policy Designs from Legal Texts. My name is Sebastian Sewerin, and later on you'll see my colleague Lynn Kaack. We're both based at the Energy Politics Group at ETH in Zurich. And we're interested in understanding the role of policy in climate change mitigation, which you can see here depicted as a stylized research framework. And one central question for our research is what policies are actually effective in inducing socio-technical change. And empirically, we focus on policies that are related to renewable energy technologies. There is, however, a fundamental problem, namely that there is no broadly accepted empirical approach for measuring or assessing policy. So that there are two sort of competing approaches. On the one hand, to measure policy, people either focus on policy instrument types or on policy design. And if you think about policy instrument types, the basic idea here is that you have one overarching label for policies, and this label then captures their fundamental design and function. And this is just an illustrative example here from the field of renewable energy policy. So you have policy instrument types ranging from voluntary agreements to regulation, to education and outreach, and so forth. The policy design, it's a bit more complicated because the literature kind of is more varied. So there are various possible starting points of how to think about policy design, basically, in the policy change and policy design literature. But the main argument always is that one label per policy is actually not enough. So we need to distinguish policy's fundamental design characteristics. And one influential approach of how to think about this is Kaack and Howlett's taxonomy of policy elements. You can see this taxonomy here on the right-hand side. And the basic idea is that they distinguish between a policy's aim, which you can see here on the left-hand side in this funnel, and on the other hand of how this aim is achieved, so the tools that are used to achieve this aim on the right-hand side. And you can then distinguish these aims and tools across various levels of abstraction. So this is basically a very useful approach to capture general policy design characteristics, so characteristics that any policy basically shares. There are also policy design characteristics that are field specific. So in our case, in relation to renewable energy technologies, we can actually draw on insights from innovation studies. And there, from this literature, we actually know that policy effectiveness depends on how technologies and applications are targeted. So the logic kind of is that different technologies have different needs, and that technology complexity and how technologies are applied matters, and this has to be addressed by policy design. And in practical terms, you can then distinguish between the technology specificity of a policy, so whether a policy addresses, broadly speaking, a set of technologies or more specific sub-technologies or even very specific technological design. And a similar logic can be applied to applications. You can distinguish between various levels of how technologies are applied. So having seen these sort of theoretical approaches of how to measure policy, the question is how these models are applied empirically. And basically, these theoretical concepts that I talked about are translated into measurable indicators. So I'll show you now a stylized version of various versions of coding schemes that we use in our research. And this includes policy instrument types as well as general policy design characteristics and policy field specific design characteristics. So if you recall this very general scheme of policy elements, we have indicators for the instrument type. We have indicators that assess a policy's scope and objective. We have indicators that measure how many resources are used to achieve a policy's goal and how the monitoring for a policy works. We also have indicators that look at how a policy is integrated with the goals and the instrumental logic of other policies that share a similar goal. And we have information or indicators for how long a policy is meant to be active, so how long its duration is supposed to be. Plus, we have indicators that assess a policy's technology and application specificity. So these indicators that are more specific, or these design characteristics that are more specific for the policy field that we're interested in. So with all these nice set of indicators, what can we actually do with them? And we have analyzed renewable energy policy mixes in 9 countries. And we did find that policy design characteristics matter for policy effectiveness, as does technology specificity. So I can't go into much more detail here, but if you want to have a look at this paper, this is where we can show this. So this is all fine and nice, but where's actually the need for computational approaches? So the problem is that so far we focus on a small set of cases, few countries, a limited time frame. But the main point is that we have to rely on hand coding of policies. And this is very time and labor intensive and not scalable. So we can't scale these approaches to all European countries, for example, and all their renewable energy policies that they ever had from, say, 1980 to now. So again, just to repeat, 2 examples from what we did in our group. So this analysis of renewable energy policy mixes that we did across 9 countries from 1998 to 2014. Here we coded 522 policies, hand-coded them by applying a coding scheme that we had developed. And that was done by a team of 4 to 5 research assistants and was supervised by 2 researchers. And this took 2 years, more or less. Another example of a policy-focused project that we are working on at the moment is the analysis of energy storage policy mixes in 3 countries, plus the related subnational jurisdictions. And here, 220 policies are hand-coded by a team of 4 research assistants, and in this case, supervised by 4 researchers. And we have been working on this now for roughly 1.5 years. So the fundamental question for us is whether computational approaches can help identify policy design characteristics and speed up data production. And for this, we were lucky to get funding for our project that is called Uncovering Policy Designs. We have around 150,000 francs from the Swiss National Science Foundations and ETH Zurich. And for the SNF funding line, that is a new funding scheme that's called Spark. And the aim of this project is to create a training data set, text corpus for labeling policy design characteristics in policies that target renewable energy technologies. And my colleague Lynn will now continue.
So let's have a closer look at the training data set that we're looking to create. So again, as Sebastian just introduced, we're interested in analyzing policy text in the field of renewable energy technologies, and we're particularly looking into instrument types, policy design characteristics, and technology and application specificity. And here we're particularly interested in the policy design characteristics and setting up a coding scheme for those. So the motivation here, again, is that hand coding of policies is very expensive and time intensive, and computational approaches can help with this problem. But if one looks at computational approaches, rule-based approaches can only go so far, and machine learning comes in handy for some of the tasks. And for training such algorithms, one needs to have a training data set. And that is what we are looking to create here. For creating the data set, we are following the 5 steps that are listed here. So we're starting off with building a corpus of legislative texts that interest us. We also set up a coding tool for our coders. We design a code book, which is the main task, actually, trying to translate what we are interested in into something that one can code. Of course, then there's going to be a longer phase of coding, and ultimately we look to publish the data. We are planning to publish this data to make it open access, for example, in Harvard Dataverse, and we're also looking to publish a coding procedure. Currently, we're working on designing the code book, and we have run initial trials for the coding. So let's have a closer look at step 1, building a corpus of legislative texts. So the scope of the corpus is renewable electricity generation and battery policies. And we're looking at English language texts. And here we have downloaded a number of US texts on the federal level and EU legislation. And we might expand this to US states legislation, which is a little more difficult to obtain. For retrieving the policy documents, we filtered by using a number of search terms for identifying renewable electricity policies. And we filtered only for those bills that have been passed. Then we downloaded them and converted them to the same format, plain text. And we also divided it into smaller sections because some of the documents can be quite long. So the 2 sources that we're using here is US federal legislation from congress.gov. We used a built-in search functionality for identifying the relevant texts. We've downloaded about 240 documents where we still need to exclude false positives. So this will be reduced further. We've split it by sections. So here you can see an example. This would be a policy that has a title, subtitle, and then section. A section is the level where we split it. For the EU legislation, we obtained these also through the official website by using a slightly different built-in search functionality on that website. They should roughly correspond to the same criteria. And we have downloaded about 500 documents. Those we have split by article. So you can see an example of an EU policy. There's title, chapter, and article. So next step is setting up a coding and labeling tool. So the next step is setting up a coding tool for our coders. And here we wanted to have the ability to code spans, including overlapping spans. And we wanted flexibility with the tags that we designed. And we have quite a few research assistants, and they should be able to access the tool at the same time and work on the same database. And we also wanted to have merging functionality. We settled ultimately on Inception, which is an open source tool from TU Darmstadt. And I'll show you later an example what this looks like. So let's get to the centerpiece of this work, designing the code book. And the challenge here is that we have to translate what is interesting from a political science perspective into something machine readable or natural language processing readable. And for that, we really needed to know what information is it that we want. And how does this information relate to natural language processing task? And we looked at the following tasks, so document or sentence classification, named entity recognition, and question answering. And after a lot of back and forth of trying out different things, we have settled on coding spans that could potentially translate into all of these tasks. So let's dive back into the policy design characteristics. So as a reminder, these are the characteristics that we're interested in. So how is the policy integrated with other policy? How does it fit to overarching strategies? Then who or what is targeted by the policy, the scope. The objectives, in particular, is an objective as target specified, and is it specified in a quantitative way or as an intention? The resources that are provided through the policy to implement the strategy addressed there. And then on implementation, who's responsible for it? Do enforcement and sanctioning measures exist? And for monitoring, how is this policy and the policy outcome monitored? And how long will the policy be in place? What are the provisions around discontinuing or reviewing it? So this are the current tags that we're looking at. Those are very many, so let's focus on one particular design characteristic. This is an example I will show you from implementation and sanctioning. So here we look at rule makers, rule takers. If a new entity is established for the implementation, if a new entity is empowered to implement this policy, if there's a enforcement actor, and if there are sanctioning measures. So let's dive into what this looks like when it is coded. Here we have an example from the EU policy. And here we have lots of language around implementation. So we're starting off with a enforcement actor that actually acts on member states. And we have clear sanctioning, so a corrective action plan. We have a newly empowered entity, the European Environment Agency, that helps with enforcement and implementation. And we have further sanctioning measures. And here you might notice that for the sanctioning, I have only coded the corrective action plan. One could also perceive to code the corrective action plan that includes, and then those provisions that are included in the corrective action plan. Since we are mainly interested in if those sanctioning measures exist at all, this is fully sufficient and might be easier to learn for an algorithm. If one would actually be interested in what exactly those sanctioning measures are, one should probably code the entire text. And I wanted to show you another example from a US federal policy that targets many of these different characteristics. So here the Hydrogen Future Act of 1996 actually talks about an implementation actor that has been newly empowered. It also talks about the scope of the policy and the intention, which is stated in a qualitative way. And you notice here also the policy amended. So this is part of the integration. And in the US, we see a lot of amendments to previous policies, and we are coding them as well. So for the coding, we have 4 research assistants that help us with the coding. Currently, we are in the middle of running trial runs and refining the coding scheme together with them. And we are facing the following challenges. So there are always some ambiguities around how much text to include in each coded span. But as I said, the less text, the better from our perspective, since we're mainly interested in the existence of certain characteristics. We have a large number of tags. So it's still the question if that takes a long time to code and if one should reduce the number of text in a sensible way if possible. And the last question is, of course, will we be able to provide enough training data per text or per class? And this is still up in the air. So going forward, we are refining still the previous steps, and we will start the coding fairly soon. And then ultimately, we are looking to publish the data, make it openly available. And we hope that this project will help public policy and political science researchers, and ultimately also policymakers, as it helps to provide an overview of which policies are available, how they're designed in the space of renewable energies. And we're looking to also run our own experiments with rule-based approaches and with learning approaches. And ultimately, it will be interesting to understand how our approach also generalizes across time, jurisdictions, and in particular to other topic areas.